Alright, so we've got 4 bonds. We need to attach 6 chlorines to the sulfur. Obviously we can't do that with just 4 bonds, so we've got another expanded octet. So we're going to put our sulfur in the middle and surround it by 6 chlorines. And let's go ahead and make everything bound to our sulfur. And if we make our chlorines happy, each one of them is going to get 6 more electrons. Oops, there we go. So this is going to give us 8 times 6, or 48. So that's going to give us all of our valence electrons that we're going to need there. So we don't need any more in our central location, or our central atom here. So this is going to be AX6, no E's. So our molecular geometry name that goes along with this is going to be octahedral. And our SP, our hybridization type, we need to have a total of 6 orbitals there. We're going to have 1 of our S's, 3 of our P's, and 2 of our D's. That 1 plus 3 plus 2 is going to give us the 6 that we have here. As far as polar, since this is completely symmetrical, there's no lone pairs of electrons in our central atom. It is nonpolar. Alright, so let's take a look at the next one here, XeF4. So a little bit odd, this strike here is a little bit odd because xenon is a noble gas and normally doesn't form bonds, but in this case it can. I think the people that first made this, I believe, won the Nobel Prize for getting a noble gas to react. So you're going to have 8 valence electrons that xenon would want, and there's 1 of them. There's 4 fluorines that would love to have 8 valence electrons. So this is going to give us basically 40, 5 times 8. Xenon, whoop, that's a 1. There's still 1 of them. It actually has 8, lucky duck. And then there's still 4 fluorines, and it actually has 7. So 4 times 7 is going to give us 28, plus 8 is going to give us 36. So do the math. 4 divided by 2, that's going to give us, well, the 4 comes from 40 minus 36. Divided by 2, that's going to give us 2 bonds. Obviously, again, not enough bonds to connect everything, so someone's got to give, and that is the xenon's not happy with 8 in this case. It's going to want more. So let's put our xenon in the middle. 4 fluorines around it. And let's just connect them with those bonds, and our goal here is to get a total of 36 electrons around here. So if I give all of these fluorines 8, that's going to give us 8 times 4, or 32. To get to 36, we need to add another 2 electrons and another 2 electrons to our xenon here. So I forget what this column is. Let me zoom up here. That's our AXE. This is going to be AX4E2. 4 because it's bound to 4 fluorines, and then the E2 because we've got a pair of electrons on our xenon and another pair of electrons on our xenon there. So the shape that AX4E2 takes is just square planar. Essentially, again, this part you don't have to know, but it helps me visualize it. Coming out of the, we're going on above the xenon and dropping down below the xenon, we've got the lone pairs of electrons. And then we've got a fluorine hanging off on one side and a fluorine hanging off another side. And kind of going into the table at a 9-degree angle, we've got a fluorine, and coming out above the table, or the, out above the paper. That bond should be like a triangle. Let me step back. Whoops. Oh, it won't let me go any further than that. Oh well. But it's going to look like a wedge coming out with another fluorine sticking out of here. So these would make a square all in the same plane. Alright, so as far as our hybridization goes, we're going to have a total of 6. So it's just going to be like octahedral sp3 d2. That 4 plus the 2 is going to give us 6. 1 plus 3 plus 2 is going to give us 6 also. Polarity, first question, are there lone pair electrons in our central atom? Yes. In that case, this is going to be polar. Alright, stay tuned for part 3.